Hi, as you can see, it's a lovely day out here today. Early August and just beautiful weather. Now this is a very busy time of year for me, so I haven't been making a lot of videos and I'm sorry about that. But I will try and get this little quickie done for Martin. Martin lives just outside of Quebec City. Or maybe he lives in Quebec City. I don't know, but he works just outside of Quebec City. And Martin wants to know about centering punches in dies when using die sets. Now, as such, a punch and die alignment in die sets isn't something that concerns or that interests many people, but it will permit me to introduce two important things, one notion and one tool. Now the notion is the notion of how a shear cut works when you punch parts out of a sheet. It's not at all the same thing as when we produce chips on a machine tool, and it's good to know how those cuts work. And the second, well, is shim stock. It's a very basic, simple tool, but we don't have the chance to hear about it very often. So let's head up to the shop and take a look at that. Hi. Punch and dies. Well, let's start at the very beginning. What is a punch and die? Well, it's a cutting tool. It's a two-part cutting tool. There's the male side that is the punch and the female side that's the die. And to explain how it works, well, I won't have to, because we've all seen this before. Ta-da! There you go, it's magic. It's a hole punch. Now, we've been using these all our lives, and they are punch and die sets. But they're a very poor example, because hole punches for paper, well, are what's called zero clearance dies. And that means that there's virtually no difference between the diameter of the punch and the diameter of the die or the hole. Now that works for fibrous organic materials, but it won't work for metal. A punch and die set cuts by shearing. And shearing is quite different from the type of cuts that we've been making with cutting tools on machine tools such as drill press, lathes, milling machines and whatnot. A shear is actually a controlled tear with some plastic deformation. And to get that with metals, we need clearance. And that means that the punch is always smaller than the die. How much smaller? Well, that depends on the thickness of material and the type of material that we're cutting. So, I have here an assortment of different types of punch and dies. We have a basic round punch and die. We can see that it fits loosely in its hole. Square, same type. Here we have a more elaborate die and the punch that goes with it for cutting a more elaborate part. Now this isn't just elaborate because the shape of the part to be cut is elaborate. It's elaborate because it's going to be mounted on a die set, and we're going to be looking at that in a few minutes. And finally we have here another punch that's the same type of punch that's going to be mounted in a die set as this one here, but with the main difference that it doesn't have its mounting screws on its flange, whereas this one does, and we'll see how that affects our approach in a few minutes also. Well, these two first punch and dies that we looked at mount directly into the punch press. There's no die set required. And that's because they're made to go in small punch presses. And small punch presses generally have very accurate rams. So accurate actually that we don't need a die set to keep them aligned. Whereas this second set of punch and die, the one here, well, it's going to be mounted in a quite large punch press. And large punch presses have loose rams. It's the nature of the beast. Well, loose. You know, a couple of thou for me is loose. And we want to keep the punch and the die aligned well within that. We're talking about a few 10,000ths of an inch in alignment here. So that means we're going to need a secondary alignment tool. And that's what a die set is. Now, I didn't keep, when I retired, any of my die sets. I just kept a few punches for memories, I guess. But I have a picture of a die set and we can look at that. Now, we see that we have the base of the die set, and on the base, well, the die is going to be assembled. And then we have the upper die set on which we're going to assemble the punch. And between the two, we have our two guide pins, which we could have 3, 4, or 5, or 6 of them, depending on the size of the die set that we're using. So we have our guide pins and our guide bushings. And those pins and bushings are quite accurate. And that is what will maintain our proper alignment. So the die set really has that function of aligning the punch and the die once everything is assembled, even if the punch press isn't that accurate. And that brings me to Martin's question. How do we align a punch and a die that is going to be mounted in a die set to ensure that they are properly aligned? Now that sounds like a no-brainer. We just put them together, tighten everything down, and voila, it's done. But it doesn't work that way, because we mentioned that we needed clearance. Well, let's look at the whole notion of clearance a little more specifically and try and understand how a shear cut works when we're cutting metal. So we have our punch, our little round 1-inch punch, or no, this is 1 1/8 inch punch, and our little die. And the punch is made to insert into the die with a certain amount of clearance. But in reality, when you're punching or blanking out parts, your punch isn't going to penetrate the die very much, just deep enough to separate the part that you're blanking. So let's take a look at that cutting action. And here we have a representation of our punch coming down, our strip, the part that we're going to blank our parts from, and our die. I've hatched it because I've cut it in two so that we can see inside, just to introduce the notion that the die isn't a parallel hole, but there is a taper after a short parallel section to permit the part to fall out, because the punch controls the diameter of the hole, but the die controls the diameter of the part coming out. That means that the part is going to be tight in that hole. If I don't have a taper in my die and my die has a certain thickness, well, I'm going to be stacking parts in there until it can fall out, and that's going to really increase the tonnage that I need to blank more parts out. Well, I said that the die is going to control the diameter of the part that comes out, and I didn't say, but I should have mentioned, that the punch controls the diameter of the hole that I'm producing in the strip. But aren't they both the same diameter? No, they aren't. They aren't, because there's clearance. And let's take a look. The punch inserts in the die with a certain amount of clearance, or else I couldn't get the cut that I need. Now what I've done here is I've blanked the part out. I see it down here. And we're going to take that edge of the part and blow it up so we can look at it a little closer. And if we do take a look at it a little closer, we'll see that in black down here, I've represented the lower part of the blank that's come out. And it has a parallel and nice square edge on its start here. It could have a little radius on the corner, but not much, and a nice parallel edge. 1/3 or 1/2 of the way up, depending on what I'm doing. And then I have, represented in blue here, a tear line that goes right up to the other edge of the part. And it's slightly tapered in, and that's normal, okay? So I have deformation and tear. And if I control my gap properly, I'm going to have a certain amount of deformation and tear and a very small burr just at the top edge here of that blank. I'm going to get exactly the reverse of what I see here on the strip. Okay, so it's going to be reversed on the strip, but it's the same event going on, it's just backwards. So why this parallel edge? Well, when the punch hits the strip, it forces it into the die. And since my steel or my brass or my material here is ductile, it's going to mush into the die. Mush, that's a real technical term. That means that it's going to take the form of the die, at least at the start. And up to a certain point, that's okay. But after a while, that becomes problematic, because if I keep squishing it into the die, it's just going to seize up and gall onto the sides. Gall means cold welded. Okay? And I don't want that. So what happens is I leave enough clearance so that it mushes or gishes into the die a small amount. That gives me my proper diameter. And then it'll initiate a tear that'll come up to the other side. On the other end, we have the opposite going on. So everything works out geometrically, and I end up with a part that has a very small burr and a good diameter. That is what should happen. Now, what would happen if I didn't have enough clearance, or if I had too much? Let's start with too much clearance. Well, if I have too much clearance, I'm going to have less deformation and more tear. It could get to the point where I have almost no deformation if I have too much gap or space between the punch and the die. And if I have no deformation, I'm going to have a huge tear that's going to end up with a quite massive radius at the start and a huge burr at the end. And remember, all this is reversed for the punch side of this action. So that means that my strip is going to have a huge burr underneath, and my blank is going to have a huge burr on the top. The burr can get so big that it can actually jam my strip into the die and cause me major headaches, because often that's going to mean that I'm going to have to tear the machine apart to get this fixed and strip out. Really not a good thing. Inversely, what happens if I have not enough clearance or a lack of clearance? Well, the reverse happens. There's a limit, as I mentioned, as to how much I can deform here. This is not extrusion, it's blanking or cutting or shearing, I should say. So if there is a limit and I have not enough clearance, I'm basically trying to force the part through the die completely with plastic deformation. And it's going to go for a while, maybe 1/3 if it's very ductile, maybe half, but sooner or later it's going to seize. Now if I have enough tonnage coming down, it's going to seize, compress again and come out, and I'm going to have a straight edge, a tear, a straight edge, a tear, and so on and so forth. And each time it skips like that, it's like a discontinuous chip in reality, while I increase my tonnage. And I am far or more than likely going to jam the press in the die sooner or later, because it's just a bad situation. So if you thought that putting less clearance is going to give you a really nice finish, it won't work. You can get a really nice finish, but that's called a shaving die, and it really doesn't work the same way. And that long and drawn out explanation brings me back to Martin's question. He wants to know how to center things up. Well, this isn't really the answer, but this tells us one thing. If I need 2/1000ths of an inch clearance per side on a punch, I need 2/1000ths of an inch of clearance per side on a punch for it to work well. That doesn't mean 4 thou on one side and no thou on the other, or 3 thou on one side and 1 thou on the other. I want a nice constant cut. I want my proper cut all the way around the punch and the die. So that means that things have to be centered properly. And that is where the die set, and that is where the shim stock comes into play. Now, the question is how to align a punch and a die once they're mounted in a die set. Well, to not make things too simple, I've chosen the more complex punch and die that I have. So let's take a little closer look at it and see what we have in front of us. So what we have here is our punch. It's a one-piece punch with its flange included, so it's been machined from a solid piece of steel, and it's been machined from a piece of steel that's tool steel, and it's already hardened and tempered. It's around 60 Rockwell, so this is hard and tough stuff. It's a cutting tool. And that's my punch. This is my die, and also has been machined from a solid piece of tool steel. It's also around 60 Rockwell, so hard and very tough. And we can see that it incorporates several holes. Now these holes have to do with stops, and that has to do with tool design, and that's not the objective of this video. So we're going to forget about these little holes here. But we have 4 large holes that are clearance holes for 1/4 inch screws. Now they're not threaded, they're just through holes. But they have the diameter slightly larger than 1/4 inch to accept 1/4 inch screws. And we have these 2 3/16 dowel holes that are already drilled, that are already reamed, and that have been lapped, so that we have what I call a finger pressure fit. And that means that if I put a dowel pin in there, I can insert it simply by pressing on it with my finger. Now, very important to note that these holes go right through the die. And that's for the design. I need a dowel pin that will stick out of both ends. But if I didn't, I would still make some type of hole, slightly smaller, maybe on the back side, that goes right through to permit me installing and retracting dowel pins easily. Holes that have a bottom in them that don't go through a part, well, it's trouble for taking dowel pins out of parts. So we have our pre-drilled, reamed, and very accurate dowel holes, and we have 4 less accurate but slightly oversized holes for accepting 1/4 inch screws. Now, on my punch, I have basically the same thing, but I'm going for no particular reason, a bit larger dowel hole. I have 2 1/4 inch dowel holes here, and I have 4 countersunk clearance holes for 1/4 inch screws. Again, these are slightly oversized holes, and my countersinks are slightly oversized, and they're countersunk obviously for 1/4 inch screws and socket head cap screws. So that's the type of screws, Umbraco if possible, a good quality screw that we'll be using to assemble this to the die set. It's important here to note that the holes, the dowel holes, are drilled through. Once again, they're already reamed and they've been lapped, so these dowel holes are quite accurate. Let's go over to the whiteboard and take a look at how we're going to get these onto the die set. But before that, I want to specify that I've been showing you the punches laid out this way because most people see that that goes into that and it's easy to see. What we'll be doing though is I'm going to position it slightly different on the whiteboard, and I'm going to position it this way when I draw it, because this goes into that, and we'll be able to see how to get our positions right easier if it's laid out in that fashion. So that's how it's going to be on the whiteboard. So here's my punch and here's my die. At least this is the artist's conception. Now I've drawn in the punch and its 4 countersunk holes, as well as the 2 little dowel holes. And those two dowel holes really aren't important right now. They're crucial for the tool, but right now we're not going to be using them. They'll come into play a little later on, and we'll see that later. But we have our 4 holes and our punch, and we have to decide, or we already have decided, because when I drew this punch and designed it, well, I decided to work on centers. And when I can work on the center of a punch or anything that needs to be assembled, I think it's a lot easier, because oversize, undersize, it's not important. This punch is smaller than the die hole, and that doesn't matter because its center is the same as the center of the die hole, whether it's smaller, bigger, or what. A center is a center. So I work on center, and I decided to position these 4 countersunk holes from the center of the punch, not the flange, the punch. So here we go. I edge found the side of the punch and the other side of the punch, the distance that separates the two in X, come back to half that distance, that's the center in X. Set that to 0. Then I edge found this end of the punch and that end of the punch, came back to half that distance, and that becomes my Y0. This X, Y0 is the center of a rectangle that circumscribes my punch. So it's the center of the punch portion of this tool. Now, when I come down to my die, I did the same thing. I found the center of the die, or I designed the die around the center of the hole of the die. And once that is done, well, I need to put it on there, I need to find its center, and I can edge find that side, this side, center in X, edge find the interior and interior, find the center in Y, and I have my X and Y0. And my holes were positioned from that 0. Now if they weren't, well, I can at least find now from that 0. Now why is it important to find the 0 on the punch? Well, because if you don't have it, you're going to have to find it. But if you've designed it into the design, well, you already know those numbers. So you don't have to edge find if you've designed it to be done on center. Now, why do we want to work on centers? Well, look, we'll see it right here. Here's my top die set. Here's my lower die set. If I look at the lower one and open it like a book, take the top off and flop it up top, that's what I have here, open and flop. And that's why I have my 2 posts here and my 2 guide bushings here, because they've been opened and laid down. From where am I going to measure? Well, I have to have designed where I want the center of my punch to be. And quite often the center of the punch is going to be the center of the force. And I'm going to want that right under the yoke of the press. And for me, I'm supposing that's about there. But listen, it's just about, it's just a sketch, okay? So that center there is X and Y from this guidepost. And that's why I'm opening it that way. I'm not turning it willy-nilly anyway. This is my reference guidepost. I've decided that. This is my reference guidepost. I've decided that. My center of my punch and my center of my die is going to be positioned from the center of that guidepost. And seen as they are quite accurate, well, it's a good reference point to start from. Now, before any of this can be lined up, well, obviously, I'm going to have to line up my posts in X, line up my bushings in X, so that they're parallel with the X-axis. Very important. Now, once that is, and that I've decided where I want the center to be, well, that'll give me a Y and an X. And that means that this center, 0, 0, is going to be up here. Sorry, the punch comes here, just as it's laid out there, on that X and Y. So what I'm going to do is indicate this hole once everything's lined up, then move Y, and then move X to come over this point, and set that point to 0, 0. The same 0, 0 that I had here. And now all I need to do is, as indicated on my drawings, come and install from my 0, 0 the 4 holes that are going to be my mounting holes for these 4 screws. Now these holes are going to be drilled and tapped because I'm going to put the screw through the punch and screw it into my upper die set. Okay? Now that will give me 4 holes, and if I do it attentively, I can get these 4 holes well within 2 or 3 thousandths of an inch. Now that shouldn't be too difficult for anyone to do, even if you don't have a readout. Remember, we had a little quickie about that. So 2, 3, even 4 thousandths of an inch. Let's not make ourselves sick. That's what we want the positioning of those 4 holes. And we can now take our punch, put it on there, put our screws in, and assemble it. And that will position it roughly in place. We can do the same exact thing for our die. Bring it over to our part and drill out, I'm just guessing here, my 4 holes. Drilled and tapped. And I can mount my die on there, put my 4 screws through, and we can mount that on our lower die set. Now, it's important to note here, because there's something I forgot to tell you. I'm going to mount the punch on the upper die set, and I'm going to mount the die on the lower part of the die set. I'm going to snug, but not tighten down those screws. I want the part to be fixed, but I want to be able to move it very slightly with a brass punch, to be able to work it around a couple of thou one way, a couple of thou another way. Because once this is mounted, it's the time to start shimming. So, if you can understand that, these are mounted on there and they're within 2, 3, 4 thousandths of being in the right spot. They have some play because remember we said that we're going to oversize these clearance holes to about a 30 seconds of clearance between the screw and the hole, and that means that I can move my part around a few thou without binding the screws. Well, now's the time to shim, and then will be the time to dowel. So let's head on over to our surface plate and take a look at the next step that we want to undertake. So here's my shim stock, and as we can see I have several different thicknesses, and most of my sheets have already been cut up a little bit because I've had this set for many years. And seeing as they're all different thicknesses, well, we can measure our punch and die and determine the amount of shear of shim that I need on each side to center one into the other snugly. I don't want it tight, I don't want to press fit, I just want it to have no play anymore between both. Now, I'm going to use this square die and this square punch as an example, and I've measured them, and a light snug fit here, something that isn't loose but that isn't tight, will work out to about 3 thousandths of an inch clearance per side, and that's about right for punching mild steel, 1/8 or under, so, but not too thin obviously. So I'm going to get my 3 thousandths of an inch shim stock sheet, and using a good pair of smooth snips, I don't want teeth on these, I don't want jagged edges, I'm going to cut a strip out, and since I'm centering a square punch in a square die, well, I'm going to want 4 parts. So let's shear off a part. Now, I've just cut an edge, and this is razor sharp. You gotta watch this stuff. But the edge that I've just cut kicked up a burr, and that's not good because this is supposed to be a very accurate thickness. So I'm going to use something smooth and hard. Could be a ball bearing if you have a large one, they work great. And I'm just going to come and burnish the edge of this part, the edges that I've just cut on both sides. Okay, and to get rid of that burr. I don't want to file it, I don't want to sand it. Burnishing will do the trick here. And then I'm going to cut it into 4 shorter parts. And I'm going to burnish the ends that I've just cut, again to not have any burrs. And then I'm going to bend over the top edge just slightly so that I get something that looks like a hook. And I'll end up with this. I've already cut the 4 parts of 3/1000 of an inch thick shim stock. So let's see how we can shim or punch with this stock. Well, I fidgeted quite a bit with this square punch to get it shimmed into the die, and it was a little awkward, but that's okay because normally I'm not freehanding it like that. In my example of my punch and my die, they're mounted snugly but not tightly on a die set. So what I would need to do then is just take the top die set and insert it onto the pins of the lower die set so that I can shake or shimmy the punch around so that it just inserts into the die by maybe 5 to 15/1000 of an inch in depth, not more than 15. And then set some spacers in there, tools, whatever, just to set the distance. And that will stabilize things. And then I can, with tweezers and my shims, come and easily shim around there because I don't have things moving all over the place. The die set is holding it. And I can obviously tap with a brass punch just lightly to get things well aligned and shim everything just properly. Now, that's the trick, and that's where the dowel holes come into play. I have those dowels and they're crucial for the alignment because once we're shimmed up, what I need to do is tighten down the screws that are holding all the punches and dies onto the die sets. Once everything is tightened down, I can take them apart again. Everything will realign perfectly when I set it back together and I don't need the shims any longer. But I will have to disassemble and reassemble this punch because I've not inserted all the parts, I'm just lining things up, and that's where the dowel holes come into play. Now these dowel holes are very accurate, and they're in hardened tool steel. Well, that's the perfect jig for positioning holes. Now this punch is tightened down now onto the top of my die set, so I can put the die set onto a mill or a drill press, drill with a slightly undersized drill from 1/4 inch through my upper die set, and then ream right through this hardened 1/4 inch very accurate hole right into my part, thus ensuring a perfect alignment between the two. I do the same for the other dowel pin, and that means that when I disassemble the punch from the top die set, when I come to reassemble, those 2 dowel pins will position this punch perfectly on the die set, as the 2 dowel pins will do the same on this lower die set when I put this die on the lower die set, those dowels that I'll install in the same way that I did the top will align everything perfectly. And that'll permit me to disassemble, sharpen, reassemble my components without ever losing my alignment. And the fact that these are hardened, well, they act as perfect guides. Now, we don't always have hardened punches, so what will I do when my punch doesn't have a holder that's hardened? Well, we'll take a look at that. I have here a punch that is in tool steel, hardened again, but that doesn't have mounting or holes that permit to fix this directly onto the top of my die set. It has to be mounted in a block, and then the block is mounted on the die set. Now, this punch is going to be mounted in a block that's going to be mounted on the superior part of the die set. Because it's a punch, it usually goes up at the top. Now, the main difference between this and the block and the upper die set and the other one is that the flange on this is integral to the punch and it's hardened. So in this case, I had no choice. I had to pre-drill very accurately my two dowel holes and ream them and then lap them out afterwards. Because it's hardened, I had to have a very accurate dimension, and because it's hardened, I couldn't have done it afterwards. So I was stuck, I had to do it, and that's not a bad thing necessarily. But in this case, I don't have to. This will be mounted in a block, and the block will be mounted on the superior part of the die set. And I'm going to make that block with my mounting holes, similar to the mounting holes I had on this one, but with no dowel holes. I'll shim it, mount it, as I did with my other example. And once it's all tightened down and I've taken the top off the lower die set, well, I'm going to come and drill and ream both the mounting block of the punch and the upper die set, all in one foul swoop. And that again will ensure a positive or proper alignment forever, because when I take it apart and put it back together, those dowel holes will always be positioned in the same place. And obviously 2 dowel holes are required. So that's the only main difference when I have a punch that's mounted in a non-hardened steel punch mounting block. Okay? Now, I came at this pretty straightforward. I don't know, Martin, if I answered the questions that you were wanting to have answered. Punch and die work is really something that I could make many videos on, and it's quite an interesting area. But I hope I did answer your question, Martin. If not, write me a note and I'll see if I can follow up with something else. So to everyone, happy machining.